Hello everyone, today we're going to resolve the LeetCode daily problem number 2563. Count the number of fair pairs. So in this problem we're given a zero indexes integer array, nums of size n and two integers, lower and upper. And we should return the number of fair pairs. The conditions of a pair I and j is fair if 0 less than equal I less than j less than n, and the second lower less than equal sum of nums I plus nums j, and also their sum is less than equal the upper. So we have an example here of nums array of 0, 1, 7, 4, 4, 5. Lower boundary is 3, upper is 6. And our output will be integer 6. Explanation: there are 6 fair pairs like 0, 3, which will equal to 3, 0, 4, which bigger than 3 but still less than 6, 0, 5 the same, it's less than, then 1 and 3 still bigger or equal to 3 and less than 6, then we have 1 and 4 the same, and the last we have 1 and 5, which bigger than 3 and equal to the 6. Also, constraints are quite big, that's why brute force approach wouldn't be possible to implement here, and we can resolve it in two ways. First of all, it will be binary search, and the second way is we can resolve it in two pointers. So, to get the idea of what we should do, we should transform our nums with lower and upper boundary into count. So we will return count of fair pairs that follow this condition. For that, if with binary search, we will use it over sorted arrays. So in both cases, we will need nums.sort. We will need to sort array, and we will look for each I the span of valid j indexes in O long of n per I. In two pointers, we will on sorted array, we will count all pairs with sum less than equal target in big of n. Then use subtractive to get the lower and upper range. So for that structure, we will use in both num and source and sort. We will use bisect left and bisect right for binary search, and we will need left and right pointers for two pointers swap. So in story, to better understand how it's work, imagine you have a row of numbered gift boxes on a shelf. You want to pair two boxes so that their combined weight falls within a safe range, not too light, not too heavy, not lower, not upper. You line the boxes in ascending weight order, sort them, and now you have two approaches. First one, you can use binary search approach. So for each box on the left, you quickly jump to find the first box that's heavy enough, and the third that is too heavy, and take the difference. With two-pointer approach, you stand at both ends of the row, and depending on whether the current pair is too heavy or light enough, you move one pointer inward, counting all valid pairs in between as you go. So by sorting once and then using these clever scans, you avoid checking every single pair one by one, and you finish in time and there are 100,000 of boxes. So let's move to our solution. So as we understand, we will return count, which will be equal to 0. Return count. Now we will look for I in range of len nums, check array, and here we will use bisect left and bisect right to find the range of indexes. So left will be equal bisect left, and nums lower minus nums I plus 1. Then we look for right, we bisect right, nums upper minus nums I incremented by 1. And our count will be incremented by each right minus left pair. And then we will return count. So let's run first check and submit binary search, and it's pretty efficient. Let's move to another description. Let's separate them and move to 2 pointers. Here we also will use nums.sort, so we will have this, but we will start with helping function, because as you understand, it's not necessary to check lower and upper. We need to check the target, that is the sum of nums plus 1, and this sum should be in the range of lower and upper. For that we will use the helper function count pairs less than or equal target. What we're doing, we find sum that is less than or equal to our target. And we also use count, which will equal 0. We will start with left, so they kind of similar. Left will be 0, and then we start with right. It will be length nums that minus 1. Then while left less than right, we will make this condition. So if nums left plus nums right less than equal target, then we will do count incrementation by right minus left, and left will be incremented by 1. Else we just minus the right side and return count. Here we will need to add the final return. We will be using this function twice on an upper and lower boundary. So count pairs less than or equal upper right side minus less than or equal lower minus 1 side. Let's run the pointers approach. Oh, let's make typo, yep. Good enough. Oh, yep. 1. Yes, mistake, not the right. And let's submit. it's even efficient than binary search. Although binary search should be run, time complexity will be big of log n, and the pointers time complexity of big of n. But again, both of them kind of use similar approach with left and right sides for checking exactly the sums of our target. The main idea what is between lower and upper boundary. So thank you for your attention. If you have any question, feel free to leave them down below, and have a nice day. Bye.